prove this by induction. I answer this question. So for n equals 1, the left-hand side equals derivative 2 dx2, and here is x multiplied sin x. And this equals derivative dx and derivative dx, x multiplied sin x. First, we calculate this part, and this equals dx. We use the production rule, so the derivative of it is sin x plus x multiplied cosine x. And then calculate this derivative. So we use the addition rule and the production rule. So this equals cosine x plus cosine x minus x multiplied sin x. Now this equals 2 multiplied cosine x minus x multiplied sin x. So this is the left-hand side. Now check the right-hand side. 1n equals 1. Here is negative 1 to the power of 1 multiply x multiply sin x minus 4 multiply 1 multiply cosine x. So this equals negative 1x multiply sin x minus 4 multiply cosine x. And this equals 4 multiply cosine x minus x multiply sin x. Compare the left-hand side and the right-hand side. They are equal. So left-hand side equals right-hand side. So the result is true for n equals 1. Then assume it is true for n equals k. Now we have d2k dx2k. Here is x multiplied sin x. This equals negative 1 to the power of k multiply x multiply sin x minus 2k cosine x. Then for n equals k plus 1, the left-hand side equals d to k plus 1, and bottom dx to multiply k plus 1. Here is x multiplied sin x. And this equals d2k plus 2 dx2k plus 2 x multiplied sin x. And this equals d2 dx2. Inside is d2k dx2k x multiplied sin x. Now we use this guy to replace this part. This equals d2 dx. Here is -1 to the power of p multiply x multiply sin x minus 2p multiply cos x. And this equals d dx. Inside here is d dx -1 to the power of p multiply x multiply sin x minus 2p multiply cos x. This equals, first we calculate the derivative of this part. We calculate this part. So this equals d dx. We use the addition rule and the production rule. So here is -1 to the power of p multiply sin x plus x multiply cos x plus 2p multiply sin x. Then we calculate this derivative, and this equals -1 to the power of p. We still use the addition rule and the production rule. So here is cos x plus cos x minus x multiply sin x plus 2p multiply cos x. This equals -1p. And we move this one to here. -x sin x. And then we combine these three together. So this is plus 2 multiply p plus 1 cos x. Now we move -1 out of these brackets. So this equals -1 to the power of p plus 1 multiply x multiply sin x minus 2 multiply p plus 1 multiply cos x. So this is the left hand side. Now we check the right hand side. Right hand side equals -1 to the power of p plus 1 multiply x multiply sin x minus 2 multiply p plus 1 multiply cos x. We just use k plus 1 to replace the n in the original form. So compare the left hand side and the right hand side, they are equal. So left hand side equals right hand side. So the result is true for n equals k plus 1. Then conclusion, the result is true for n equals 1. And if true for n equals p, it is also true for n equals k plus 1. Therefore, the result is true for all n belongs to positive integers by the principle of mathematical induction.